Hi everybody! So in this video, I'm going to show you how to use a multiplication chart to look for prime and composite numbers, to find prime and composite numbers, okay? So before we move on, you need to remember a few things about, let me refresh you a few things about prime and composites. First of all, prime numbers only have two factors, 1 and itself. So for example, the number 11. The only way I can get to number 11 is by multiplying 1 times 11, 1 and itself, okay? Now for composite numbers, it can have more than two factors. What that means is that, for example, let's look at number 4. I can multiply 1 times 4 to get to 4. I can also multiply 2 times 2 to get to 4. So the minute I can multiply another set of numbers other than 1 to get to 4, then 4 becomes a composite and no longer prime. So this is the definition of what prime and composites are, and it is a very good definition for you to have as we move on when we're working out our examples. Okay? Now, the multiplication table is really good if you're working with small numbers. And I'm going to show you how to use the multiplication chart in order to figure out some of your primes and composites from a list. Okay? So for example, if we have this list right here of 3 numbers, I'm going to just do 3 numbers or 4 numbers. It's okay. Okay? I have 13, 7, 1, and 18. How do I use a multiplication chart to help me figure out which one of these are primes and which one of these are composite? It's very easy. All you have to do is, if you have this type of a multiplication chart, all you have to do is you have to make a line right there to show yourselves, or to, if you notice, these 2 columns right here are just counting numbers. They're just counting numbers because they're just like how you count, 1, 2, 3, 4, 5, and so on and so forth. And it's the same with these 2 columns as well. They're just counting numbers. So they have nothing to do with the multiplication process. But anything in this area, however, in order for them to be in here, they are a multiple of some other numbers. So for example, 4 is here because 4 is a multiple of 2 times 2. So the minute any number is present in this area, okay, that tells you that these numbers are composite. So all of these numbers will belong to the composite families. Okay, just so you know how to use the chart. So let's look. Let me go ahead and erase the C, big C, and go back to the problem that we were presented with. Now, let's look at 13. Can we find 13 anywhere in this area? As you can see, you have 12 here and then it jumps to 14. I have 12 here and then it jumps to 15. 12 here and it jumps to 16. I have 10 here and it goes to 15, and 12 here and that goes to 18. So there is no 13 in this composite area. Therefore, this is a prime. Now, if you look at 7, again, 7 does not appear in this area. It appears up here because it is a counting number, okay? But that tells us, because it's not present in here, that it is also a prime, because there's only one way to get to 7. It's 1 times 7. Number 1 is a little tricky. Number 1 is neither prime nor composite. So sometimes when the tester tries to help you to see if you really understand what prime and composites are, they throw in a number 1. You have to say it's neither. Okay, it is neither prime nor composite. Now let's look at number 18. Can you find number 18 in here? I bet you can find them in many different places. Look, I got 1 here, 1 here. I got another one that's erased, 1 here, and there may be more places. Because they appear in this composite area, this number is definitely a composite number. So that is one easy way you can use a multiplication chart to help you find primes and composites. Now, let's test this for another set of numbers. what if we have 30, 23, 36, and 49? Okay? Again, can we find 30 in here? Let's see. Oop, I can find it right there, so it is composite. When you can find number 30 one time in here, you do not have to go all over the place to look for all the other 30s. Because the minute this number is divisible by any other number but 1, it is already a composite number. Don't waste your time to look for all the 30s that is in the composite area. Okay, now let's look at 23. 23, let's see. I have 21 here, and then it skips to 24. So I don't have 23. I have 20 here, and then 24. No 23. 20, 25, 21, 28, 16, and then I don't see 23. Do you see 23? Well, if you do, let me know, because I don't see it. I'm going to say that it's prime. Okay, now let's look at 36. Ooh, I see a 36 right here. That makes it composite. I don't need any other proofs. 49 is a tricky number because it's an odd number, and we typically think that odd numbers are primes, but look, 49 is in here, so it is composite, not prime. Okay? So one of the questions you may have is, what if we have huge numbers? What if our numbers are not on this multiplication chart? And that can happen as well. So for example, I can give you, or we can be given a list of numbers that are like this. Okay, so let's just work with these two numbers. Sheet. It's okay, I want to work with one more. Okay, how about that? Okay, now these are huge numbers. And you know what? If they were composite, if we were to extend this multiplication chart out, these numbers may be in the multiplication chart. But because our multiplication chart typically is a 10 by 10 or 12 by 12, we have some limitations. So what else can we use in order to help us find primes and composite? We can use what's called divisibility rules. Okay? And it is a huge word, but it means something very simple. When you see the word divisibility, it's written like this. Okay? Divisibility, what you hear is the word divisible. That means you can divide. Okay? So any number that can be divided or is divisible by 2, it has to end in 0, 2, 4, 6, and 8. What does that tell us? That tells us that this number has to be an even number. So let's look at this number. Is this even? No, because the ending number, it doesn't matter what it begins with, but the ending number is not even. The ending number is 9. Therefore, this number right here is not divisible by 2. And anytime when a number is not divisible by 2, it is also not divisible by 4, 6, or 8. Okay, it's that simple. Now, let's see if this number, if there's a rule for a number that is divisible by 3. So how we can check for the divisibility of a number, if it's divisible by 3, is to add all the digits up. Okay, so we're going to add the digits. And then whatever that sum of the digits is, we're going to divide it by 3. So let's look at this number. We have 2 plus 6 is 8, plus 9 is 17. Now we go here, because we're seeing if it's divisible by 3, we look at the 3's columns. Can I see 17 in the 3's column? Or if you know your multiplication facts, you can easily say 17 cannot be divisible. You can't divide 17 by 3 evenly. So therefore, this number is not divisible by 3. And it's really neat because any number that is not divisible by 3, it is most likely not going to be divisible by 9 either. So the only other ones, actually we have a few more that we can test for. So numbers that are divisible by 5s and 10s are pretty easy because these numbers will end in 0s or 5s. Because if you skip counting by 5s, you will see that there is 5, 10, 15, 20. All these numbers ends in 0s or 5s. Okay? And And then to test for 10, which is an easy one too, the number will have to end in 0. So the number has to end with a 0. So the only other things that this leaves us with is the divisibility rules for 7, 11, and 13. And I'm sad to say, but there is no way, there's no rule for us as of right now to test for divisibility of 7, 11, and 13. You actually have to divide those numbers, and I'm going to show you with this one example. So for this one number right here, we already established that it is not divisible by 2, 4, 6, or 8, and it's not divisible by 3, therefore it's not divisible by 9. It doesn't end in a 5 or a 0, so it's not divisible by 5, and it is not divisible by 10 because it doesn't end in 0. So let's see if it is divisible by 7. So I will have to divide. Okay, I will take this number. Sorry, I'm gonna move this so I can show you the work. And I will divide it by 7. I can use my multiplication chart. Since I'm dividing by 7, I can put my finger on the 7's column. And I know 2 cannot be divisible by 7. So I put a 0 up there because the first number in the 7's column is actually 7 itself. 2 is too low. So then I check to see where in this column I can go as close to 26 without going over. And it looks to me like 21 is the first number that I can get to. And in order for me to get to 21, I can make 3 groups of 7. Okay? So now I'm going to subtract. 6 minus 1 is 5. And 2 minus 2 is 0. So then I just bring down this 9. Again, my finger goes back to the 7 because now I have to divide 59 by 7. So I slide my finger down and I'm trying to see if I can multiply 7 by any number as close to 59 without going over. And it looks like the 8 is the closest to it, but it is not exactly it. That means that even if I divide this, okay, even if I made 8 groups of 7, I will have some leftover, and I will have 3 leftover. Because of this leftover right here, it tells me that this number is actually not divisible by 7. And if you have time, you can go into it and you can check for 11 and 13 as well. But I have done this already, so I can tell you that it is actually not going to be divisible by 11 or 13. So this number right here is a prime number. Now, let's look at this number right here. Okay, so let's use the divisibility rules again to help us to quickly see if this number is a prime or composite number. Again, the minute this number is divisible by any number that is other than 1, it is automatically composite. You don't have to test it for all of these numbers, okay? So let's look. It ends with a 7. That means it's not divisible by 2, 4, 6, or 8. Let's see if it's divisible by 3. Let's add the digits up. When I add these 2 digits up, I will get 8. So 8 plus 7 equals 15. And I'm trying to see if it's divisible by 3, so I put my finger on the 3's column and I see if 15 is in there. If you know your facts, you can also see that 15 divided by 3 is 5. Because this number is divisible by 3, it is a composite. You don't have to prove any more. Now let's look at number 800. There are a couple of ways to do this. But you can see because it is 800, it ends with a 0. Notice there's a lot of numbers that it is divisible by right off the bat. I have it being divisible by 2, so far 5, 10, and of course if it's divisible by 2, it may be divisible by 4, 6, and 8 as well. So this one is definitely a composite number. Okay, so guys, I hope that this video helps you to use the tools that you already have, which is the multiplication chart, to help you find primes and composite. It is not hard, but for larger numbers, you will need to know, first of all, the definition of what prime and composites are, and the second thing you will need to remember are the divisibility rules. If you do not remember it, this is the part where I would probably ask you to make a copy of it. There are divisibility rules are all over the place on Google. You can find images of it, and you can also start memorizing it. It's not that hard to memorize. There may be some songs on YouTube to help you to memorize divisibility rules as well. But in order for you to find primes and composite, the two best tools for you is a multiplication chart. For small numbers and for larger numbers, you will need to refer back to the divisibility rules. So that is it, peeps. I hope this was helpful for you. Have a good one.